Hello and welcome to TidyX episode 180. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
Yeah, my name's Patrick Ward. Thanks for checking in with us at Tidy Tuesday. As always, be sure to like and subscribe on the YouTube channel. Drop questions, comments down below. And if you enjoy our work and feel like it supported you, we enjoy doing it. And if you'd like to support us, we do have a Patreon page. We're happy with that. That said, we're going to jump into episode 180 of TidyX today. We're going to do a 180 and we're going to talk about some TidyTuesday data, which is where we first started this whole thing way back
Oh,
100
way back in
episodes. Yeah,
2020.
yeah, we used to just do TidyTuesday explanations, and then it sort of branched off into other things that you all wanted to see by liking and subscribing on the YouTube channel and dropping your questions and comments down below. And so today we decided to turn back the clock a little bit and talk about some TidyTuesday data.
Yes, so let's do that. Before we get too far into this, we're going to load our two libraries that we're going to be using today, which I guess technically there's three, but there's Tidyverse for our data manipulation needs. There's this library by a guy named Brian Haven called trelliscopejs, which is really sick. I'm going to show you how it works at the very end of this episode, so stick around if you want to know how this really cool library works. And then we are now going to load in our data using the TidyTuesday R package, TidyTuesday R : TT load, and the date that we're pulling it for. So we're cheating a little bit, recording this in May. Looking back into April, we found a data set that we thought was like kind of fun, smallish, so it was really easy for us to explain it to you. So you load that in, it downloads the data for us, and it also gives us the README explaining what the data is. And so this week we're looking at objects that were launched into space. And so all this work for TidyTuesday is being kept up by a couple folks on a purely volunteer basis. So really want to give them a shout out for trying to make sure that this continues, because TidyTuesday has been a great program and a great project since 2018 to try to give folks a new data set every week to try to practice, combined with a really nice README explaining what the data is and where it came from. And so this is all public. You should definitely do it if you haven't yet. If you haven't worked with this data set yet and you go to visualize it, please tag us so we can look at it. We want to see the different ways that people are visualizing all this stuff. So anyway, yeah, this is the space data. And so we're looking at how many objects were launched into space over the years that that we care about. So I think this is from like 2000 or not 2000, 1950s ish,
Looks like it says
1960s.
up there since 1962. Yeah.
Yeah, so since 1962 until present, objects that were launched into space by the various countries. And so let's pull the data object out of the TT data. It's the outer space objects, and we're going to assign that to space objects. We can kind of take a head of it. It's a little bit difficult or just to print it, so we're just going to take a head. And there's four different columns: entity, code, year, and number of objects that were launched. So it's pretty clear what each of those are. Entity meaning the country, code meaning the country code, or I guess it could not just be country. It could be like the European Space Agency or something like that.
Or
So the code.
world. There's one that's just specific to the whole world as well.
Awesome. Yeah, and then there's year and there's a number of objects that were launched. So it's as datasets go, this isn't the most complicated one. So what are ways that we might start to explore it, Patrick?
Yeah. So first, we might look at some of the different categories or entities that are there. So starting with a simple count. So we're taking the object and we're just counting how many times across the 1962 to the present, each entity, or in this case, we can see their country names, and there's the world. Each entity is represented. So no shockers, Russia, United States making up the kind of biggest contribution here, and then Japan and China slowly behind. And there we see the European Space Agency checking in at number 9 with 39 years worth of things being sent to space. This isn't telling us how many things they've sent into space, just that they've contributed counting across the entire data set, they've contributed 67 rows of data, right? And then
Hmm.
there's 142 which are NA. So I don't know.
Oh, I just ran code for the next one, so this could be some
Oh,
entities
oh,
that
oh.
don't have a code. So like
Yes, entities with no
USA,
code. Yeah. Oh,
Russia.
yeah, yeah, yeah. So that might be. Yeah, I'm not sure what it would be, but
Well, that's the point, is that there isn't a code for it.
yeah, interesting.
I mean,
Okay.
if we wanted, we could go rogue for a second here and filter code is
No,
NA,
capital C.
and then we can just do a table,
Yeah.
or we do a pull, yeah, on entity.
Yeah.
I guess we could just do unique. We don't need the counts.
Yeah, distinct or something. Yeah, unique. That'll work.
So AppsCo, European
Okay, so like
Union,
European Space Station doesn't NATO. Interesting.
ESA, Arabsat, Intelsat. So different satellite companies.
Yeah.
Intersputnik, Rascom, Starsem. I don't know. I'm not much of a space knowledge
Yeah.
person. Good
I
English, I
do.
do.
Yeah, I do feel like they should be attached to a country though. Like I don't know.
NATO?
Maybe the country
NATO?
itself didn't. Yeah, though that's a, a combination of many countries.
Yeah.
Um,
Eh.
all right. Well, anyway, how many things did we send to space is answering a different question, which is now grouping by year. And we're summarizing the objects per year. So we're summing the number of objects there. If in case there's any NAs, we just have NA.rm equals true. And obviously we can see that, this is pretty much growing since 1961 or 62. It seems like there's a continual rise all the way into obviously the last 4 or 5 years where you have now private companies, SpaceX and
This is our
Blue.
assumption, at least.
Yeah, I mean they're sending stuff into space, so I'd imagine that's what's contributing to some of this. Who knows? But we can visualize it. So Ellis, what are we going to do here?
All right, so the first thing we're going to visualize this is trying to see what is the trend of the number of objects that are making it into space over time. Because obviously we can look at that table that we just made here, but that's not the easiest to quickly like grasp the scale of things. So what we're going to do is we're going to take space objects, we're going to again group by year and again summarize to get n. We're going to throw that into ggplot and set the x-axis to be year, the y-axis to be n, which is, again, the sum of the objects for that year. And we're going to use geom line to plot it. And so now it's going to draw lines across between every point that we have to help us visualize it. And so would you look at that? Holy cow. Is that kind of crazy? How, starts here, the space race occurs. There's this consistent kind of low level of activity. Um, at some point, didn't NASA get like defunded or something? It
Yeah,
had a
I feel
reduction
like
in
something.
funding,
Yeah,
so
yeah,
that might
something. Like
have. I mean, not that NASA's everything, but like, might have been a little bit of a dip there. And then,
that.
yeah, in the last, 15-ish years or so, it's really taken off. And yeah, our assumption is these private companies that are sending more stuff to space.
Yeah,
Um,
I got to
but
imagine it's
again,
a
not
lot of it.
having verified that, don't take that as truth.
Uh, one of the things is that code, while very easy and workable, did take up a lot of lines because we had to do a group by and a summarize. And one way you can do this in ggplot, which we haven't talked about before, but is relatively easy to do, is in 3 lines, we can get the same thing without having manipulated our data by just directly piping to ggplot. And then instead of trying to use a geom line, we're actually going to use this stat summary function, which is going to summarize our Y data using whatever function we want. So in this case, we're using the sum because that's what we used above, but we could use the mean number of objects per year if we wanted, or the median number of objects per year, or the standard deviation, I suppose, if you were interested in that. But basically, stat summary is going to do everything above for you in 1 line, and you just say, hey, the geom that I want here is line. We could change that, of course, to bar or call if we wanted, bar or something like that. We
let's
could
let's
um,
show it. Let's show this off first because it
it's going
looks
to be the
exactly the
same.
same.
So no change. Yeah.
Now if we do bar,
if you bar maybe, yeah. So now we get bar plots and yeah, so different points would work. Yeah. And so if you wanted points in a line, you would do another stat summary and put geom line, and then it would overlay the line.
can you list multiple?
That's a good, you know what? I've never,
You know, we're living and learning together.
yeah, I've never tried that, but I suppose I don't see why you couldn't. I think you need one more parenthesis.
Yeah. Nope.
No. Okay. So you need two lines there.
Darn.
Still, simple, just a simple way of doing the same thing above without doing the extra transformations to the data. So it just gets you directly to the plot if you're quickly exploring things, and then you maybe find that, oh, this is interesting. This is going to be a feature that I need to generate for my analysis. Now you go ahead and do the data transformation.
Yep. Cool. So we did some initial look on there now, but that doesn't really give us a whole lot of like granularity, right, into the data and understanding it. It's just like, wow, the world has sent a lot of stuff into space. And actually thinking about this now, we might be double counting because it's going to count world in there. So,
Um,
yeah.
oh, yes, this will, because
Yes, this is double counting.
world is an
Yeah.
example variable, which I remove it somewhere in here though.
Yeah,
There
here.
it is. Okay.
So
Yeah.
now what we're curious about is what if we were to now facet by country, but we don't want to include every single country. That's a lot. So what we could do instead is okay, figure out who are the countries that are most likely to have interesting histories. And that's probably in this situation going to be who has sent the most or who's been doing this for the longest number of years. And so what we're going to do is we're going to take space objects. We're going to again count by entity. And this time we're going to sort the results. We're not just counting it and letting it return it in alphabetical order. We're going to have it return it based on the number of times that entity appears in our data set. We're going to filter out world. And we're also going to filter out any times where n is, or keep any cases where n is greater than 39, because that would be, they've been doing it for 39 years. So let's throw this here, and let's take a quick peek at which entities have been doing this for a long time. And the reason we picked 39 is because we ran this in the past, and we know if we filtered by 40, there would only be 6 countries, and that's a little bit small. So we set it to be 39. And we're then going to get Russia, US, Japan, China, France, Germany, Canada, the European Space Agency, and India as the top 9 countries that have been involved in the space, sending stuff to space
Yeah.
for 39 years, or have participated in 39 different calendar years, to be clear
Yes.
about what the data are. So we pull that out and assign that to countries of interest. And now we can just easily filter out the space objects into keeping only those countries of interest, so we can do a few more types of plots here. So the first one we could do is we could do space objects small. Again, do the aesthetics X is year, Y is number of objects, do a geom line, but this time we're going to color by entity. And this means that every single one of those entities will get their own line colored in its own way. We're then going to set the theme to be classic. We're going to remove that gray background. And we're going to set some labels. So we're going to set the title of our plot to be number of objects released into space each year. We're going to say that the color is country, so it's going to update that rather than entity. And then we're going to set our y-axis to be number of objects. And we're going to then put theme legend.position equals top. So legend by default appears on the right-hand side. By saying top, it's going to appear at the very top of our plot. So now when we run this, and I make us a little bit smaller, you can see that we have our title there. We see country, but oh, that's not very helpful,
No.
because one of the countries is sending a lot of crap into space right now. And so it's scaling out every other country, and that's not very helpful. So Patrick, how would we solve this?
Well, one way to solve it is to put everything into facets. And one thing that I did here was inside of the facet wrap on line 68, I set the scales to equal free.y. So basically that means, and we've done facet wraps before, each country is going to get, each of these 9 countries are going to get their own little box on the plotting grid. if we set scales to be free Y, each country is going to get their own Y axis. Now, the only thing I will say about this that I often do when I'm producing plots like this, and I have to set the axis on this Y scale to be free, is I often set a subtitle that says, note, Y axis is unique to each facet, or in this case, I would say to each country or entity, because I don't want the readers to be skewed by, for example, looking at Germany there's a lot of ups and downs, but it's really easy to think if you just glanced at the plot, like, oh, Germany is very similar to Japan, but not really. Japan's peaking up at 25, or the United States is peaking up at 2000. So I just want to make sure China, for example, it's easy to look at Germany and China, which is right above it, and say like, oh, it looks like they're at a pretty similar rate of sending things into space over the years. However, notice the y-axis, Germany peaks at 12 and a half. So that means they probably have their peak there in the 2019 or whatever that is at like 12.
Mm-hmm.
However, China is all the way up over 150. So sometimes just setting a subtitle to make sure it's explicit for people is important.
Yeah, exactly. But this is a great way. The only change in the code that you need to do in order to do this plot, as Patrick mentioned, is to add in after your geom line, add a facet wrap. Technically, you can add this wherever. We could have added this, at the very end here because it's a GG plot and it's just like add your different layers and tell it what to do. The layer of the geom does matter because that tells you the order in which to add the different plot elements, but a facet wrap could be added at the very end.
Yep.
But that's not the only way to facet things. And so I hinted at this earlier in the episode here. There is this really cool library called trelliscopejs. And if you want to be visualizing your data, here it's static, right? You can't say you wanted to actually compare Canada and India. You have to kind of jump between the two of them. You can't put them right next to each other. But if you use facet trelliscope, on the small thing. So this is just replacing. Did I totally deleted
You have
it?
a plus sign there.
Yeah,
Yeah, there it is.
there we go. I just replace facet wrap
Yeah,
with facet trelliscope. Uh, why did you not work?
there it goes.
There we go. All of a sudden, all right, we get this nice view that just pops up over here. We can go over into grid view and we can increase the number of rows and columns. And all of a sudden we can see all 9 of our different entities here. We could reduce the number of rows and columns and kind of scan between all of them. So we can do that. So that's pretty cool. But you can also go down into this filter menu here, click on entity and say, I only want to look at China versus Germany. And it'll show you that exactly.
It's interesting. I've never used this before until now, but the one thing I noticed is it doesn't retain the coloring, the country colors.
It's because each country or each one of these plots is plotted separately. So each one
It's
of these,
separating them. Yeah.
yeah. So each one of these is its own plot. So it runs the code ahead of this
Yeah.
to do that.
Well, that's pretty cool.
Um, at least Ryan Hafen, if you end up watching this, leave a comment. Let us know if that's actually how it does it. That is me just guessing based on what gets
Right.
printed into the console, seeing what's here.
And it looks like
Uh,
you have options for different types of summary statistics there below your selection. So you could do year mean or year median, for example. Is that, oh, it's going to add, it's not going
mhm.
to change the plot. It's going to add values down below.
Yeah, so what you could do is you can remove your entity filter, and
Yeah.
now you can say, I just want to view all countries that are less than
Oh,
70.
yeah.
So this, yeah, their total number of objects launched is less than 70.
Love it.
Does that make sense? No.
I think you have to provide it with the range there. So
1 to 70.
yeah, there you go.
Oh, I guess
Uh,
this that no, that doesn't make sense because Japan's definitely done more than 70. Maximum number of objects?
has Japan done more than 70? I don't think so. China has. I don't think Japan has though.
Yeah.
So I
Well, I
think
did
that's
75,000.
oh.
Here, if we filter by 75
Huh. We're learning here too, folks. We haven't used this term before.
together.
Pretty cool.
But yeah, I just think this is a really cool tool to be able to use and allows you to explore this data in a very interactive way. And you can
Yeah.
kind of build this up over time and really build a sense for exploring your data. I mean, we don't even need to lead or filter by number of objects. We could
They
just do it
keep everybody in
for
there.
every single entity that exists and see it's running this for every single um,
Every entity, yeah.
yeah, so it's taking a little bit longer because it
So
needs to do it for
so
every single one
we've
of them.
done a few different types of we've done a lot of different types of interactive plots using using ggplot, using some combination of plotly. This is fun time series data. We could certainly do, a plot moving over time as the line goes up for the world or something like that. We could also model this data as sort of time series type of data. If there's something that you'd like to see and see us expand upon besides our simple exploratory data analysis here, leave the comment in the on the YouTube channel and maybe we can turn that into an episode for next week.
Yeah, but yeah, leave a comment down below. Tell us
Yeah.
how have you used TrellisCopejs in the past? How have you used it? I would love to hear all those things. But thank you so much for joining us for 180 episodes of TidyX. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on X at OSP Patrick. At Tidy_explained is where we both are on X. Of course, you can always hit us up on the YouTube channel. That's the easiest way to get in touch with us. Like, subscribe, drop the questions and comments down below. Let us know what you'd like to see. And if you'd like to donate to the show, we are always grateful for anything that you'd like to provide on our Patreon page.
Thank you all so much and keep on exploring your world.